Okay, we want to calculate the area underneath the parabola y equals x squared from 1 to 3, and we're going to use our result that the area function is f at x minus f at a, going from a to b. In this case, a is 1, so our left bound is 1, our right bound is 3, so area at 3 will be f at 3 subtract f at 1. So what is the antiderivative of f at x? Well, we add 1 to the exponent. This is the power rule. Add 1 to the exponent, get 3, and we divide by that exponent. So it's 1/3 x cubed. And you can always test that by using the power rule again of differentiation, and you get x squared. So f at 3 will be 1/3 3 cubed, 1/3 of 3 cubed, minus 1/3 1 cubed. So let's work this out. 3 cubed is 27, 1/3 of 27 is 9, minus 1 cubed is 1, 1/3 of that is 1/3, and 9 minus 1/3 is just 8 and 2/3. So this region here, bounded by x squared and the x-axis, to the left 1, to the right 3, is exactly equal to 8 and 2/3. Our next example, we want to calculate the area bounded by the upside down parabola 4 minus x squared and the x-axis. Now I have a diagram included in this example, but if you weren't given the diagram, you would have to sketch this parabola, and you'd have to determine the left and right bounds, which will be the intercepts, the x-intercepts. So in this example, you can see what they are, -2 and 2, but how would you figure that out? Let's just quickly review that. You set it equal to 0, right? And then you need to solve for x, and x will be positive negative square root of 4, so you have two intercepts, positive and -2, which we have in the diagram here. So our area, using our formula here, rewrite it. The area of at 2 is equal to f at 2 minus f at, well, the left bound would be -2. So let's figure out what f at x is. F at x is the antiderivative of 4 minus x squared. So the antiderivative of 4 is 4x. The antiderivative of x squared, we add 1 to the exponent and divide that, will be 1/3 x cubed. Okay, so let's evaluate f at 2. So we substitute 2 in there. So 4 times 2 minus 1/3 2 cubed. And then we want to subtract f at -2. So we'll substitute -2 in there. So that's our area. We just have to figure it out. Simplify here. We have 8 minus 1/3 of 2 cubed. 2 cubed is 8. Divided by 3 is 8/3. Subtract 4 times -2 is -8. -2 cubed is -8. -1/3 of that is positive 8/3. So let's work this out. We have minus -8, so that's plus 8, minus 8/3, 8 and 8 is 16. Negative 8 thirds minus 8 thirds is negative 16 thirds. Common denominator here would be 3, so we'll rewrite 16 as 48 over 3 minus 16 over 3, and we get 32 over 3. And that's our area. Okay, we want to calculate the area below the sine graph from pi over 6 to pi over 2, and I have a diagram here. So I'm going to calculate the area of this region here using the formula a at x equal to f at x minus f at a. In this example, will be a at pi over 2 equals f at pi over 2 minus f at pi over 6. So your left bound pi over 6, your right bound pi over 2. There it is right there. So let's figure out the antiderivative here. Antiderivative of sine x is negative cos x. So going back here, we want to evaluate f at pi over 2, be negative cos pi over 2. Subtract f at pi over 6 would be negative cos pi over 6. Okay, so these are special angles. This one here is 90 degrees, and this one here is 30 degrees. These are some you should know without a calculator. The cos of pi over 2, you can refer to the graph of cos over 2, which is not here. You have to memorize that. Cos of 90 degrees is 0, so negative 0, so we'll just put 0 here, minus, we have cos of 30 degrees. Now that is a special triangle, so let's draw that special triangle. 30 degrees, let's put that in here, so that's 30, that's 60, that's 90, so that's 2, across from the 30 is the 1, and then you have the root 3 over here. So the cos of this 30 degrees is root 3 over 2. Root 3 over 2. So 0 minus the negative of root 3 over 2 is just positive root 3 over 2. So there you have your region is exactly equal to root 3 over 2.